Good afternoon. My name is Brett Glencross and I'm the Technical Director at IFFO, the Marine Ingredients Organisation. This afternoon, what I'm going to talk to you about is marine ingredients and how we believe that these ingredients are really setting the benchmark for sustainability and responsible sourcing for feed ingredients into the 21st century. As a bit of an overview of how I'm going to frame this argument, I'm going to look at where we are now in terms of this supply of marine ingredients and why I believe that they represent one of the best value options in the marketplace. We'll then look at how we believe marine ingredients lead sustainability, and then we'll follow up with how marine ingredients lead responsibility in terms of raw material supply. So let's start with where we are now. When we look at the nutritional proposition that marine ingredients provide, they're still amongst nature's best nutrient sources, not only in terms of the absolute bulk density of nutrients they supply, in terms of their protein level, their lipid levels, but also the balance of those nutrients that are found within these resources is really almost unmatched. Their balance of essential amino acids like arginine, histidine, the branched chain amino acids, and lysine, of course, are almost near ideal for the production of most intensive animal industries. They also provide quite a unique level of EPA and DHA, those long-chain omega-3, which is so important for immune function and inflammation management. But they also bring other nutritional elements too, things like phospholipids, nucleotides, and also the non-proteinogenic amino acid taurine, which plays a role in particularly some animals like carnivorous fish species and cats in terms of how they function. So we still really consider these animals, these ingredients, both fish meals and fish oils, amongst some of the most cost-effective and arguably the nutritional benchmarks in terms of which all other ingredients are still compared. In terms of global supply, we can sort of see over the last 50 years, supply has been relatively constant at around about 5 million tonnes. There was a period during the late 80s and early 90s where this peaked at close to 7 million tonnes. And since then, what we've done is we've drawn back that production to around about 5 million tonnes consistently year in, year out. Fish oil, on the other hand, has been constant around about 1 million tonnes per annum, but it's beginning to grow again now. It's reaching around about 1.2 million tonnes. What we can sort of see over the past decade, or 2 decades in fact, is there's really been this steady supply of around about that 5 million tonnes each year. In terms of the application of fish meal and fish oil across different sectors, what we've seen is really an evolution of the use of these resources, basically moving towards the most efficient use and the highest paying markets. In the early days, you can sort of see that originally fish meals were largely used by pig and poultry industries. Then with the emergence of aquaculture, a more efficient industry in terms of the nutrient transfer process, those industries could afford to pay a higher premium. And so obviously the resources started to move in that direction. To where we are now, where about 80%, 75 to 80% of all fish meal is now used by aquaculture, and poultry is almost disappearing completely, and pig production makes up around about 15 to 20% of global use of fish meal. Fish oil, on the other hand, presents a slightly different story in that traditionally it was largely seen as a waste product of the fish meal, and it was largely used in industrial purposes as a lubricant and also as a fuel source. Then with the advent of aquaculture and the need for high energy dense diets, like we have in, say, salmon feeds, for example, we started to see the resource used in that sector. It was around about this time, though, that people began to understand the nutritional values of fish oil, particularly the long-chain omega-3s, and we started to see direct human consumption of that resource. And this has been really the growing part of that sector in the last 20 years, as we've seen increasingly large amounts of fish oil going direct to human consumption, which of course is the most efficient use in terms of human access to those nutrients. Although aquaculture still uses somewhere between 66 and 75% of global fish oil production. In terms of prices, we've seen in the last 5 to 6 years, fish meal has actually been incredibly stable in terms of its price. There was a lot of volatility coming from the early thousands into the early teens, peaking around about $2,400 US per ton, but it's been quite stable now at around about $1,600 US a ton for about the last 6-7 years. Contrasting that, though, has been the prices of fish oil, and fish oil has recently surged up to almost $4,500 US a ton. And this is really just been driven by the value the market is playing on those very valuable omega-3 resources, and also the absence of any real competition in the marketplace with respect to their supply. So where do we see things going? Well, if we look at just the last 20 years and the growth of the aquaculture feed sector, we can see in the year 2000, there was around about 13 million tons of aquafeed produced. And that aquafeed production used around about 3 million tons of fish meal. So arbitrarily, it was around about a 23% inclusion across the entire sector. Fast forward to 2020, when we have 52.5 million tons of aquafeed, and we're now using 4.1 million tons. So the total volume of fish meal used in the last 20 years has actually increased by over 1 million tons. But that proportional use is now down to only 8%. And this is largely because there isn't a lot of scope for growth in the fish meal sector. So what we're increasingly having to use is this resource as a strategic ingredient, not as a bulk supply of nutrients. There's other things which are now playing that role, like soybean, for example, and corn, which are applying the bulk nutrient supply part of the aquafeed game. So how do we believe the marine ingredients lead the sustainability story? Well, let's start off by actually sharing a definition of what we mean by sustainability. And I'm taking the example here that was proposed by the former chief economist for the World Bank, Herman Daly, who proposed a series of 3 operational rules to define ecological sustainability. Number 1, non-renewable resources such as minerals and fossil fuels should be used no faster than the rate at which renewable substitutes can be put into place. 2, that pollution and wastes must be emitted no faster than a natural system, ecosystems, can actually absorb, recycle, or render them harmless. And number 3, which is the one that really applies to us here, is that renewable resources such as fish, soil, and groundwater must be used no faster than the rate at which they regenerate. Now, if you want to find the origins of these rules, please follow the link there on Wikipedia. There's a huge amount of resources there, understanding what we mean by sustainability. But we're looking at this daily rules approach because it provides really clear, simple metrics that we can basically assess ourselves against, and ones which we think are very clear and tangible. So what does sustainability mean in fisheries then? Well, maximum sustainable yield, MSY, is that proportion of a fish population that you can catch that delivers the highest annual catch that can be sustained over time by keeping the stock at a level that produces maximum growth. And that tends to be about this midpoint carrying position of the population. So it's about identifying this proportion of the population that you can keep the population at that rate there, where it's growing at its fastest rate. You're not getting maximum population in the system, but the population is growing healthily over time. In terms of what that means in terms of fishing effort, this is the maximum sustainable yield that you can harvest from that population. The other alternative position that people often talk about is maximum economic yield. That's the greatest difference between the value of what you're harvesting and the costs associated with catching it. And in reality, what tends to happen is fishing effort tends to be expended somewhere in between these two lines here, between MEY and MSY. But for argument's sake, what we're going to stick with is the MSY, maximum sustainable yield, is generally the benchmark of what sustainability means in fisheries. When we look at how that's applied, we see that effective fisheries management is critical to maintaining populations at around that MSY, or yield at about that MSY. So, and we see that increasingly most fisheries in the developed world are now being managed by independently set quotas based upon a targeting of that maximum sustainable yield. Now, this generally requires modern fisheries to be regulated to operate within a quota-based system. And we can sort of see here on the right in the diagram here, this is an example of the world's largest fishery, the Peru North Center fishery. This is the data from IMAPRE, who's the Institute of Marine for Peru, that actually sets those quotas. And you can sort of see the quotas that's been set in each case, and also the actual catch that's occurred in each year. And you can see in some years, they actually don't even catch the full quota for various reasons. But it's important to note that there's been a big shift in fisheries management over the past 20 years. The things that used to happen in the 20th century, particularly in the developed economies, are not so much happening now. In fact, what we see when we actually look at some of the data, this is a paper published only a couple of years ago by Ray Hilborn and colleagues, we can see that effective fisheries management has been instrumental in actually turning around global fish stock status. Here we can sort of see that the biomass relative to the biomass for maximum sustainable yield, it was going negative and having a trajectory to get us into trouble. But by bringing in effective management, we can see the well-managed fisheries are rebuilding, and we're starting to bring them and turn them around. And a key part of that is actually being about regulating the fishing effort, the amount of effort being expended to target the maximum sustainable yield. That last diagram was more about global fisheries, particularly in the developed world. What about this small pelagic fisheries which are generally those targeted for production of fish meal and fish oil? Well, we can sort of see in this study here, which was published only earlier this year, that the relative biomass for those fisheries is actually staying around about above that MSY target of 1. So it's on track to actually maintaining its expected biomass. And a key part of this story has actually been the reduction in relative fishing effort to make sure that we don't extract more than that MSY, that maximum sustainable yield biomass. So what we can sort of see arguably is that in many respects, small pelagic fisheries are amongst the most sustainable of all fisheries. But there's been a range of metrics that have been applied to how we understand the story of sustainability and the use of marine ingredients. There's a range of these metrics out there. We have on our webpage basically a critique of all of them. The problem with all of these is they're all simplistic assessments of what we believe is actually a very complex issue. Things like feed conversion ratio, which is a really nice simple metric of showing the efficiency of which feed is used by an animal production system. And then there's the fish in, fish out ratio, the FIFO, which explores how much fish is actually used to produce farm fish. And then there's the evolution from that, which is the forage fish dependency ratio, which really looks upon the quantity of wild fish that's used in feeds to produce a certain volume of harvested fish. And this is the one that's been picked up by the Aquaculture Stewardship Council in some of their criteria. More recently, there's been an evolution of that to what we call the economic fish in, fish out ratio, which has sort of been, I guess, another evolution of the FFDR story. And it's, I guess, principally pitched as an improvement of the FIFO option, in that it applies an economic allocation weighting to the relative values of fish meal and fish oil that are being produced. Sort of in some respects, in that way that it aligns with some of the agreed standards that have been used in feed sustainability assessments that's been proposed by the Global Feed Life Cycle Assessment Institute, the GFLI. Now, when we compare all those metrics side by side, whether it's FCR or FIFO, eFIFO or FFDR, and we look at that for a range of major industries or aquaculture sectors, what we can sort of see is across the board, there's been significant improvements in nearly all sectors. If we just look at total fed aquaculture and FIFO, it's gone from a total FIFO across the entire industry of 0.47 down to now 0.195. That means that for every 1 kilogram of fish being used, you're effectively producing 5 kilograms of farmed fish on that assessment. We look at the economic allocation, it's even actually more efficient. And the FFDR, now we're talking just about those fish that are harvested from the wild for fish farming, it's even more efficient again. But in terms of those metrics, we actually don't really think that using simplistic metrics is actually that constructive to anything in terms of this argument of sustainability. We think to do that, you actually really need to be able to compare apples against apples. And that requires you to use an assessment framework that allows you to make effective comparisons amongst all different materials. For our thinking, the best option here is probably life cycle assessment. And this allows you to compare a full range of environmental effects that can be assigned to either products or services by quantifying all the inputs and outputs associated with material flows and how those material flows affect the environment. To do this, we basically have to compile an inventory of the relevant energy and material inputs and environmental risks associated with those. And we can assess those not just against 1 or 2 metrics, but about 18 and 19 metrics or impact categories. You can sort of see how these all line up over here. These are the different impact categories. The one that we might be most familiar with from life cycle assessment is global warming potential, otherwise known as carbon footprint. But you can see there's many others here that allow us to compare all different types of materials and products or processes against each other. So increasingly, this has been seen as the mainstream way by which we can establish the environmental credentials of any process or product. When we look at, say, a whole range of different feed ingredients that might be used, say, for example, in a salmon feed, here I'm looking at just the carbon footprint, the global warming potential of each of these, including the inputs of land use change. We can sort of see that we find that marine ingredients in particular actually compete very effectively on this framework. Fish oil compared to rapeseed oil is almost about 1/3 the carbon footprint of rapeseed oil. Fish meal compared to something like, say, soybean is almost half the carbon footprint of soybean, for example. There is, of course, other materials out there which are much lower, like wheat, but then wheat comes at a significant nutritional discount. It's only 11% protein, whereas fish meals are 67% protein. So there's some trade-offs there that could have to be made in terms of understanding how different raw materials contribute to that story and what their environmental costs are. In terms of this information that I'm showing you now has actually come from the GFLI, and the GFLI acts as an independent database that has close to 1,000 different ingredients where you can access all this information. So it actually allows us to compare all the ingredients we might use in a feed for arguably anything on a head-to-head basis using a comparable agreed framework by which we all can look at the same ingredients by comparing effectively apples against apples. What you do when you go through that process, and this is not data from the GFLI, this is data from my colleague, Dr. Richard Newton at the University of Stirling, we see that in reality, all ingredients have sustainability trade-offs. Some use more land, some use greater amounts of biotic resource use, and the carbon footprint varies quite markedly across all of those. So something like, for example, anchoveta meal actually has quite a small carbon footprint, but of course uses a very high dependence upon biotic resource use, but it uses a very small amount of land. Compare that to something like, say, for example, black soldier fly, which has quite a large carbon footprint and relies either directly or indirectly on a very large amount of land use, but has a relatively small biotic resource use footprint. So we can sort of see that when we look at raw materials or ingredients, there's lots of trade-offs that have to be made when we look at the various different options available. Okay, that's the sustainability story. What about responsibility? Well, let's start off by defining what we mean by responsible sourcing. So responsible sourcing, and what I'm talking about here, is referred to supply chain responsibility. This is a commitment by the companies involved in the supply chain to take into account social and environmental considerations when managing the relationships with suppliers. And again, you can see those definitions where I've identified those from. So this is really about looking at that triple bottom line in terms of social equity, environmental protection, and economic viability in terms of the responsible production of ingredients. When we look at how we verify that, or how we actually demonstrate that certain materials or ingredients are actually effectively contributing to responsible supply, this is where the role of certification programs comes in. So let's just take the fish meal supply chain or the aquaculture production chain. We can go from a process of fish being caught in a fishery, which is often under a certification program governed by, say, the MSC, for example. Those fish then go to a fish meal, fish oil factory, which is then transported either to the human chain directly or to a feed factory, so aquafeed, which then makes feeds for fish farms, which then, of course, those fish go to a fish processor, which then go to retailers, which then comes to the consumers. And the other key part of the certification process or program here is Marine Trust, which plays principally a role directly at the fish meal and fish oil factory, but also then brings in engagement with respect to the fishery and also the supply of byproducts from fish processors into the production of those raw materials as well. We can then also see that there's other groups like Global GAP, ASC, and also BAP that play a role at the feed factory and the fish farm and the fish processor in terms of the certification programs there. So we can see from fishery, fish meal factory, transport, all the way through to feed factory, fish farm, and processor. There's a range of different certification programs that play a role in providing that third-party independent assurance over the responsibility of the producers in that supply chain. So what we can sort of see that those different certification programs cover different things. The Marine Trust Standard is a tool that enables producers of the marine ingredients industry to demonstrate responsible practices at individual factories. And this might be practices such as where the raw materials come from, with they're being sourced from responsibly managed fisheries, for example. Also, the eradication of the use of IUU material being used as raw materials, and also transparency of the supply chain from the fish being caught to the actual delivery of those raw materials to the feed manufacturer. Contrast that with the MSC. The MSC, of course, is a fisheries standard. It's used to assess if a fishery is well managed and sustainable. And this standard really reflects the most up-to-date understanding of the internationally accepted fisheries science and management and how it's been applied with respect to an individual fishery. And those MSC standards are developed in consultation with scientists and the fishing industry and various conservation groups, as is also the Marine Trust standards. So let's consider scale and where we're at with, say, for example, the Marine Trust standard, which is the standard that represents the marine ingredients industry. We can see that now we're looking at more than 50% of the global fish meal production is now part of that certification program. That's representing over 3 million tons of marine ingredients that has actually been part of that program. If we look at that against, say, the next best in class in terms of the other ingredients out there, and this is information that I managed to get from the European overview in terms of the soybean used around the world, we can sort of see there's around about 350 million metric tons of global soy production, of which we can see there's only around about 33 million metric tons, which is sustainable soy guidelines compliant soy. So that's less than 10% of the total production, which is actually meeting third-party standards in terms of their certification. So it's a large volume, 33 million tons, I'll grant you that. But in terms of the global production, it's not even close to the more than 50% that the marine ingredients has. So this is why we argue that marine ingredients is really the leading ingredient in terms of that demonstration of responsible sourcing as well. It goes beyond that though. One of the key mantras we have in the marine ingredient sector is this mantra is no such thing as waste. We know that the majority of fish that is caught and farmed for human consumption, only about 50% of it is eaten. And so increasingly what we're seeing is systems are actually being designed for efficiency and recovery of the parts that are uneaten to actually bring them in as renewable raw materials that actually allows us to recapture those nutrients and that omega-3 from the system. And this allows us to better capture this in a circular thinking approach to actually retain those nutrients within the system. We can also see that fisheries that once considered forage species, things like Atlantic herring and pilchards and sardinella, are increasingly now being redirected to human food. But in the process of doing that, they still supply byproducts. For example, Atlantic herring, more than 80% of it goes to human consumption, but of that human consumption component, around about 50% of that biomass at least goes into the rendering industry to make fish meals and fish oils. One of the beautiful parts about that circularity process is that circularity story actually even improves the sustainability story further. So not only does the responsibility of better using those fish that we catch for human consumption when we can provide a really nutritious resource for human consumption, but the byproducts from that actually produce a really sustainable high value ingredient. And a simple way to look at that is when we compare the carbon footprint, say, of herring that's caught for fish meal versus the herring byproducts that are used for fish meal, we can see that it drops the carbon footprint by 50% straight out. And there's a range of reasons for that. It's largely to do with what we call the economic allocation process associated with the value of the byproducts versus the value of the human consumption part. In terms of the byproduct story, we can see that byproducts are becoming an increasingly important part of the marine ingredient sector. We can see in 2021 that we're more than about 70% of global fish meal production is still coming from pelagic and demersal whole fish, but we're seeing now more than 30% of the fish meal production globally coming from byproducts, things like pelagic and demersal byproducts, like we talked about with the herring, for example, and the blue whiting byproducts, but also things like tuna byproducts and aquaculture byproducts from tilapia, pangasius, and salmon are increasingly making important contributions to fish meal supply. When we look at that in terms of the fish oil supply, what we can see now is that more than 50% of global fish oil production is now coming from byproducts. Key things like the pelagic and demersal byproducts, tuna, and also the aquaculture story are increasingly contributing growing amounts to the fish oil supply. In terms of the total volumes, what we can sort of see now is about 1/3 of all fish meal, fish oil produced in the world now, around about 2 million tons, is coming from byproducts. Aquaculture contributing around about 770,000 tons, and fishery biomass contributing around about 1.2 million tons of fish meal and fish oil. And when we look at basically the projections of groups like the FAO, they actually see this as a growth sector into the future. We're currently sitting around about, say, 1/3 or 32% as of 2021 of the total volume of fish meal and fish oil coming from byproducts. You see in this projection here of the fish meal, it's around about 30%, which is what I showed you in the previous figure. But the FAO projects this out to 2020, this growing and becoming an increasingly important part of the marine ingredient supply. So in summary, we still see that marine ingredients are largely still the nutritional benchmark. They remain highly cost-effective sources of important nutrients. We can see that their supplies have stabilized over the past couple of decades, and they are increasingly being targeted by both aquaculture and direct human consumption markets for use of these ingredients. But the ingredients are now seen as strategic ingredients. They're no longer a bulk supply of nutrients. We have to rethink our role, our relationship with these marine ingredients to basically use them as strategic materials to allow us to better use larger bulk volume, cheaper ingredients. In terms of sustainability, we believe that marine ingredients are leading the sustainability story in terms of global feed ingredient supply. Sustainability remains paramount to the industry. It underpins their ability to retain social license and retain the ability to go out year on year and catch reliably the stocks that they rely on. In fact, we can see that small pelagic fisheries are considered amongst the most sustainable of all fisheries. And we see the sustainability metrics that are being used are moving more towards holistic forms of measurement like LCA that show that marine ingredients have some significant advantages over many of the other ingredients in the marketplace. And in terms of responsible supply, we can see that marine ingredients are one of the most independently certified of all feed ingredients. They're way ahead of some of the other competitors in the feed ingredient sector. We can see that byproducts are increasingly becoming a major contributor to production. You know, there's no such thing as waste anymore. We use all of the fish. We have 100% use thinking now in terms of the way in which we use marine resources. And circularity, this way of actually designing systems, whether it's fisheries or aquaculture, to capture all the nutrients that we can from the production, is going to become an increasingly important part to the sector. And we can see that that's actually going to allow us to underpin some small growth into the sector going forward. But we're still only ever going to be seen, I think, in the future as a strategic ingredient of a high value. Thanks for your attention.